within 2 minutes, shall we start the program, sir?
Okay, perfect. Okay.
Okay, sir. Thank you. Good evening, everyone. I am Prithviraj, working as assistant professor in Christ College of Engineering Technology. I welcome you all for this Atal sponsored 6-day online FDP program. For today's session, I welcome Mr. Dr. Albert Alexander S., Assistant Professor in Science in Vellore Institute of Technology. And today's topic is machine learning for battery health prediction and optimization. I welcome you, sir.
Thank you, sir. Shall we start?
Yes, sir. We can start.
Okay. So thank you so much for your invitation. So today we are going to see
Ma'am.
how we are going to integrate machine learning models for prediction of battery performance. So before we are going to talk about on machine learning, so today I am going to divide my session into two parts. One part will be on the general problem and what are the basic things we have to assess from the battery. Second part will be on the machine learning models. Okay. So let me share the screen for the today's session. So here, I hope my screen is visible and my voice is audible. So if you have any queries from your end, you can post in the chat box. Okay. So this is the slide in which we stopped in my Tuesday session. Okay, so these are some of the objectives of electrical vehicle. Okay, the problem statements. Okay, because directly nobody can swim in the machine learning. We want to see the problems. Okay, after seeing the problems, we want to see how we are going to solve the problems with help of machine learning. Normally this electrical vehicles, it's having some objectives like, we want to improve the fuel economy and to reduce the fuel emissions, and also we have to reduce the cost, and also we have to make it as affordable for the people, and also to reduce the weight of the car, because the previous session we also discussed about on the weight of the vehicle and the power rating. Obviously the weight will substantially will raise, so our objective is to reduce the car weight. So what is the advantages of electrical vehicle over the conventional engines means? The biggest advantage is on the regenerative braking, and because here we don't have the engine, so we are replacing the engine with a motor, and also we can able to see that because of that the efficiency will be increased and the emissions will be decreased, and it can able to cut the emissions by global warming by 1/3 or 1/2, and so we are reduce the dependency of the fossil fuels, and some states even they offer incentives whenever you're owning a high, electric vehicle, and it's twice times more efficient than the conventional engines. Now let us move on to the charging modes. Okay, actually the battery charging is classified into two major types. One is called as a slow charging, one is called as a fast charging. Everybody they are working with a fast charging infrastructure, because everybody we want charge to be done very fast. Even present day the Apple model of mobile phones, you can see that how fast it charges when you compare to the conventional mobile phones. Fast charging. So when we talk about the fast charging, fast charging is also called as a DC charging. Okay? It is also called as a DC charging pile or DC charger, whereas the slow charging is called as a AC charging pile or onboard charger. So the slow charging can take some duration of 10 hours. So minimum 6 hours to 10 hours to charge. Okay. So for example, if you're going to the charging station, no driver or no owner is ready enough to wait for 6 hours to 10 hours. They want to charge very fast, less than an hour for complete charge. So they prefer the DC charging. But the infrastructure costs, okay, for building the charging will be more high for fast charging, whereas it will be less for the slow charging. When we talk about on the impact on the battery life, so the battery life impact will be more in the fast charging, and the impact on battery life, that is how the battery deteriorates or decreases the lifetime. So will be less in slow charging. So now we are going to talk about on one problem statement, that is on the battery swapping technology. Okay, so this we already discussed in our previous session. That is how we are swapping the battery. Okay, so that is the electrical vehicles will arrive to the swapping station, and based upon your entry code, you will be given in the queue number, and based upon that the charge will be takes place, and then it will be. I just keep this one. Okay. So now I'm going to talk you about on the energy storage system, because this FDP is about on the battery management system. Normally, whenever we talk about on the energy storage system, we talk about only on the batteries. Okay, especially the people know only the lithium-ion battery or the nickel metal hydride battery. That is we call as a NIMH battery. That's all for EV. We are talking for EVs. In addition to that, there are some energy storage elements. They are called as ultra capacitors. They are also called as a flying wheels, flywheels. Okay, it is a mechanical based energy storage element. An ultra capacitor is the combination of battery plus capacitor. Okay, normally the battery will have some chemical. Okay, capacitor will not have chemical. Okay, so it will use the charge by using the dielectric strength. Combining the features of battery and capacitor is called as the ultra capacitor. Okay, so this is the way how the ultra capacitors will look like. Now this is the basic classification of the battery. Okay, so what the battery which we are talking about is comes under the category of electrochemical batteries. Electrochemical, because it speaks about on the electro and as well as chemical. Okay, electrochemical batteries are classified into two basic types. One is called the classic batteries, and one is called as a flow batteries. Classic battery means it starts by lead acid, lithium polymer, metal hair, sodium nickel chloride, sodium chloride, lithium ion battery, lithium sulfide, sodium ion, sodium sulfide, nickel magnesium hydride. Similarly, from the flow batteries, we talk about on the redox oxidation, vanadium battery, and the zinc bromine battery. So this is the normal classification what we follow in the electrochemical. Okay, when you go across to the proper chemical based batteries or chemical based, we are not going to talk about as a batteries, because batteries comes under only under the classification of electrochemical. When you go for the pure chemical, we call that as the hydrogen or synthetic natural gas. We normally call it as a SNG, synthetic natural gas. So these things are a very good storage medium. That is the reason whenever you talk about on the DST, okay, they make a call for proposals exclusively in the hydrogen. So they call the proposal for the hydrogen generation, hydrogen transportation, and hydrogen storage. Still, they need some kind of unique ideas for the generation of hydrogen, transportation of hydrogen, storage of hydrogen, because it's one of the very great energy storage element, especially when you're working with the fuel cells, or the hydrogen-based vehicles. Okay, this is the basic fuel. When we talk about on the pure electrical, okay, so we should not say that battery is a electrical component. Battery is a electrochemical component. It is not a electrical component. In electrical, we talk about two major things. Okay, so we can talk about on the capacitors. Okay, capacitors is the one and only. Okay, so one and only energy storage element in the electrical. Okay, even we talk about an inductor also. Inductors also stores energy. Okay, yeah, in the electrical field. Okay, so we can talk about on the inductor and capacitor. So we talk about inductor. Okay, when we talk about inductor, it stores energy in the magnetic field. So what is meant by SNES? SNES stands for superconducting magnetic energy storage. Okay, where the capacitor is purely electric field. Okay, it stores energy in the electric field, and this SNES stands for the magnetic field. So SNES stands for superconducting magnetic energy storage. Okay, you can ask a question, sir, why everybody focus on battery? Why they are not focusing on other kind of energy storage elements? Why not the hydrogen? Why not SNES? Yes, we can use, but the thing is that the cost involved. Okay, cost involved, and also purpose of safety, the people are working more on the batteries. But now many research scholars, they are working with the comparative analysis of the battery. They are also working with the supercapacitors. Supercapacitors means I combine the electrical nature and also electrochemical nature, combined with each other, we call as a supercapacitor. Later I will tell you why we need a supercapacitor. When we talk about on the mechanical based energy storage element, we talk about flywheels. Flywheels means, that is we are giving some input of force, and that makes the blades to rotate, and that makes the energy to store. Okay, and then we talk about on the air compressed energy storage. We'll talk about adiabatic process, diabatic process, or compressed storage of liquid air, pumped heat electrical storage, pumped hydro kind of. So when you talk about on the pumped hydro, okay, I know the people, those who are studying this subject like renewable energy, you may think about the words like pumped hydro. What is meant by pumped hydro? It is also comes under the category of the geothermal energy storage. Okay, geothermal plant. So when we talk about geothermal, what the people will say, we are extracting some energy from the earth. That is called geothermal. But it is similarly like a pumped. So whenever you travel in the bottom of the earth across some 15 kilometers or 60 kilometers, okay, you can able to experience a very high amount of heat. So that heat, we are going to take it outside through the pumped well, and then we can able to store for the electricity and also for the storage. That is the thing. But nobody is ready enough, okay, to extract that particular heat and connect it to the thing, because it is not a continuous process. Okay, sometimes we can able to extract the heat, but if we cannot able to get the heat at a larger scale, so it is only under the research. When you talk about on the thermal energy storage, okay, so we talk about on the heat, either with the hot water or PCM. So many people are working with the PCM. What is meant by PCM? PCM stands for phase change material. Okay, phase charge material. So even presently we are working with the PCM. Okay, so that is a very important energy storage substances. Okay, so where we can say it's one of the thermal energy storage material. Okay, so PCM is a technique. It's normally a technique. So in this technique they use some materials, okay, to absorb or release a large amount of latent heat at exactly when a constant temperature during some kind of phase transitions. Okay, so whenever that's why it is called as a phase change material, because it transition takes place by converting the solid to a liquid at that particular time. Okay, it can able to absorb or release. Okay, so we call as a PCM, as a energy storage element. It is also thing, but we know, but most of the students, they work only on the what also say, that is on thermal. What is meant by CSP? CSP stands for concentrating solar power module. Okay, so this CSP module is also used to store the heat energy. Okay, so we have to understand everywhere we talk about chemical, electrical, mechanical, thermal, electrochemical, but we should understand that in the mechanical, what it stores the energy in the form of heat. Okay, anyway, the word is common, storage is common, but in the electrochemical, what it stores the potential difference. Okay, it stores some energy. We call that as an energy. So from the battery, so that's the thing. In the thermal, what we want to store, we want to store some heat. Okay, so here also mechanical or even the electrical, what it stores, capacitor, what it stores, some charge. We call that as a charge. Okay, so like this, even though the words are used for the different items, we say that they all are called another classification of energy storage systems. Okay, we should not limit our discussion only with the battery. We have to concentrate on the other energy storage elements also. But at the meanwhile, you typically we want to understand what application we work with, whether we want to work with on the applications of electrical or mechanical or thermal kind of. So, what is the challenges of this battery? Okay, so this is the requirements of a battery. Whenever you want to have a good battery, this battery should have the peak and the pulse power, and also it should have the specific energy, high energy, and it also to provide a high charge to maximize your regenerative braking, and also the battery has to provide long life. This is the expectation of a battery. But what are the challenges of the battery? Even yesterday, one of the participants, day before yesterday, they asked one question. What are the challenges? Okay, the challenges, one of the greatest challenges, recyclability of the battery. See, whenever you want to write a proposal, a project proposal, or whenever you want to write a paper, a research paper, okay, we have to list out the problems, and then you talk about on the solutions. Nowadays, many places the people talk about on the solutions, but we want to make clear about the problem statement. Then only more solutions will come. It's just like a movie. So whenever we taking some presentations, whenever we are writing the books, or whenever we are taking the classes, so we want to make some impression to the people that in the movie, that is the critical story should be registered in every participants. Okay, so we can able to provide the critically, we can able to provide the participants, that is where we can able to make sure that how we are going to take care of this one. Okay, so in this particular thing, okay, in this particular thing, we can able to understand very clear about the problem. And one important problem, what we are going to discuss today, is we are going to accurately techniques are needed to determine the battery state of charge. Okay. What is the present state of your battery? For that, we need some techniques. For that techniques only, we are going to discuss about the machine learning. Okay. So today the topic given to me is machine learning. Okay. For solving some problem. Even I can use machine learning, okay, to work with the how to recycle the battery. Okay, I can use machine learning to predict the lifetime of the battery. I can even make use of, this is my research area, the second one. I'm going to develop some abuse tolerant batteries. Okay. What is meant by abuse? Okay, in a workplace, many people will abuse each other. Okay, that is bullying, or by making some fun of others. We normally call that as abuse. Okay, is using some abuse words, or kind of how we can able to tolerate those words or tolerate those things. So we want to tolerate some things in the certain places. So the batteries are, they're not they're called as a non-living things. Okay, so we want to, whenever the fault comes, the battery will get damaged. So we are working on some technology such a way that how we are going to make these batteries, okay, to be an abuse tolerant one. Whenever there is a fault, how the battery reacts for this particular faults. Okay, how the battery reacts for this particular pulse, and then so for these two challenges, we are using the machine learning. I will tell you how we have used the machine learning. So before that, I will also explain you how the machine learning tools are helpful in solving these problems. Okay, that will be a very interesting one. Okay, so next we talk about an ultra capacitor. So we know the battery is or the energy storage elements, okay, which is useful whenever you're going to drive the car in the place, okay, a normal plain place, okay. But whenever you want to climb the hill, let us say that this is going to be the hill, okay. Whenever you are going to climb the hill, this power from the battery will not sufficient or the to provide a sufficient energy to climb the hill. So what you're going to do, up to the plain surface, you are using the battery to travel. Once you reach over here, you switch over from battery to ultra capacitor. But many people are thinking in a wrong way that, instead of battery, you use ultra capacitor. No, that is wrong. Okay. A battery cannot be replaced. A battery has its own unique properties. Okay, so up to here you work with a battery, and after that the battery cannot be able to provide such a thing. Okay, so for that, at that time the ultra capacitor will help you. Okay, which are the places ultra capacitors will help you means whenever you want to start the car after the very cold climate, so the battery will not helpful, so you switch over to ultra capacitor. And whenever you want to climb the hills, use the ultra capacitor. And whenever you want to make use of the regenerative braking at the higher level, you use the ultra capacitors. Okay, so where in these three regions the role of battery is quite limited. It does not mean that the battery will not work. The battery will work, but its maximum efficiency we cannot able to get while we are working with the battery. So that is the reason we are going to make it across ultra capacitors. Normally the ultra capacitor, it stores electric charge. It's a liquid layer between your electrolyte and the conducting electrode. So it is just like a combination of it's a combination of a battery and as well as the capacitor. So flywheel, as I already mentioned you, it is a mechanical storage element. The principle of operation is very simple. That is, whenever the air makes this particular thing to rotate, and that gives the enough force, and that force will be an input for your motor or generator set. Okay. So for an example, this mechanical energy is converted to electric energy with help of the generator, and then it is stored. The energy is stored. This electrical input is stored, and after that, the same electrical input will be taken. Now this electrical is converted to mechanical with help of your motor, and then you can able to connect it to the loads, for example vacuum housing or something kind of things. So that is, it's a two-way communication, like a motor generator sets. What is the advantage means? It is having no acid like a battery, no hazardous material like a battery. It is not affected by temperature, but it delivers a very smooth flow of power. That is it. Just like we are just making some force. We are just having some force as an input. That's all. Okay. So normally, whenever you talk about on the tidal energy, the renewable energy, the tidal energy, or you talk about on the wave energy or water plants, what they are doing, they are just creating a force. That's all. Once the force is created, you now the mechanical energy in your hand. Now you use the devices for converting that mechanical to electrical with help of your generator or vice versa. Now I'm going to explain you some basics about the battery, because I already shared this presentation to you. Okay, I have not deleted any of the slides. The complete PPT I have given to you. So even at the later stage, you can able to have a look at the basic concepts of this battery. Now, I made a comparative analysis of the battery for the various EVs, what they are using. So let us take about on the General Motors, Ford, Toyota, Honda, Hyundai, okay, Chrysler, BMW, and Nissan, and Mitsubishi, Tesla, Tinker, Daimler, Benz, and which are the countries we made a comparison, and mostly what is the model of the vehicle. It's a four-wheelers, and we also made a comparison of the battery technology. So I can be able to see that most of the battery they are using the lithium ion. Okay, most of the batteries are using lithium ion stands first, and second one will be called as the nickel magnesium hydride. Okay, so only these two batteries are highly used. Okay, as of now in the popular cars. Okay, I have made use of a selected car manufacturers, and I found these two batteries holding the present thing. And I also made a comparison between these two batteries. Okay, one is on the nickel magnesium hydride and the lithium ion. So even we can say that the same lithium ion battery only we are using in the cell phones and also in the laptop. But unfortunately, the life cycle of these batteries are very low. That is the reason many people, those who want to change the mobile phone, the only problem what they will say, the first problem, their battery has has gone. So for that, what they will say that my charge is not withstanding. So they can easily change the battery and use the mobile phone, but they will change the mobile phone because only reason is battery. The first case is battery. The second one is the display has gone. Only due to these two problems, many people are changing the battery as per the survey. So when we talk about the challenges of the lithium ion, we can say that's a life cycle and it's abuse whenever some kind of fault comes. It is not that much of these are some of the challenges. Okay, but it is having a very high energy efficiency and good temperature performance and low self discharge. It's not a self discharge; it's a self discharge, low self discharge. Okay, and recyclable parts. The parts can be recycled. Okay, so because we know what are the parts are associated with that particular thing. So lithium ion stands at the first. Now I want to give you some basic definitions of battery before we are going to talk about on the machine learning. Okay, so for the next 10 to 15 minutes, we'll be discussing about on the basic definitions on battery. So normally the battery is composed on the individual cell. Okay, so earlier the people, even now they're talking only as a cell phone cell. Okay, everybody know that it is called cell. Okay, cell is the proper word what they are people they are using, but we should understand that a cell is called as an individual component. It's an individual component. Okay, so in the battery, we'll be having such like cells, like 6 cells or 8 cell battery will be having, and it will be plastic encapsulated. So we are talking about individual cells as like our solar thing. Each and every cell will be having two current leads, okay, positive and negative. Each and everything will be having, okay, and they have the separate compartment. Okay, each and every cell will be having their own electrodes. One is on the anode, one is on the cathode. Okay, anode and cathode. Okay, and also a separator. Separator means which separates the anode and cathode during the electrolytic process at the electrolyte. This is the normal working. So we should not say that the complete battery will have only one anode or one cathode like that. No, each and every cell will have its own anode, its own cathode. Why we are using anode and cathode? Because for the proper functioning of the battery, I want to go for the redox action. What is meant by redox? Redox is the basic operation of a battery. So in a battery, redox stands for reduction, OX stands for oxidation. Reduction, oxidation. Reduction means it will lose one oxygen atom, and oxidation means it will add one. So O minus and O plus. Okay. To perform this O minus and O plus, only we are using this anode and cathode. Okay. Why we want to use anode and cathode? So the anode and cathode are used only because of to oxidize and also to reduce. So during the charging process, we can able to see that. So for an example, redox oxidation takes place during the charging, and the discharging, it's a reverse process, oxidation, reduction. That's all. So we can able to understand that redox, now it is reversed to oxidate. That's all. This is the normal working of a battery. Okay, so to perform the function of the reduction and oxidation, we are using the anode and cathode. So actually the anode will be always a metals, okay, whereas the cathode will be always like a halogens, oxyhalides, or a gases kind of. For an example, if you're working with a zinc battery, so let us even take the lithium ion battery. So here the lithium refers to the anode because lithium is a metal. Ion refers to the cathode. So every battery, the names are given based upon the materials what it was used for the anode and as well as the cathode. That is the normal terminology. Even we can take a zinc chloride battery. Zinc is a metal, so zinc is an anode. Chloride is a halogen, so it will be taken for a cathode. That's the thing. Why we are using anode and cathode? To perform the function of the reduction and oxidation during charging power, and it will be the reverse. So that is the normal working of a battery, what everybody should know. Okay, we cannot say that during anode and cathode, the positive ions, negative ions, it's all the very basics, So that's what we need to teach to the students, how the basic working of the battery takes place, how the cell. So it will be just like a fascinating one whenever you are teaching these concepts to the students, rather than just drawing a block diagram, putting an anode, putting a cathode, connecting with this particular thing, and making an electrolyte. And we have to also, students will also say that, sir, why you are putting the distilled water in the battery? Okay, whether the distilled water is anode, no. Whether the distilled water is a cathode, no. Whether the distilled water is electrolyte, no. Why we are going to use it? Why we are going to use this distilled water? The role of distilled water is they are just like a catalyst. Catalyst. What is meant by catalyst? Catalyst means they will not involve in the chemical reaction, but they will stimulate the chemical reaction. Okay, in certain family, some people, so they will not have going for work and they will be in the house, but they will be a moral support. We call them as a catalyst. So here for the in this battery, we use the, because many students will ask a question. So why are you using this distilled water for the UPS and all? So you should say that these are working as a catalyst. That is to appreciate the chemical reaction, to stimulate the chemical reaction, to start the chemical reaction. That is to understand that everything is in the level. Okay, so the people, they will say that they think, even now they think that the distilled water is an electrolyte. No, electrolyte is not a distilled water. Okay, these things will stimulate the chemical reaction process. Okay, now we are going to talk about on the module. Okay, so module means, it is composed of few cells which is being connected to each other. For this module design only will give you what is the voltage of a battery. For an example, if each cell is about 2 volt, okay, each and every cell is about 2 volt. Okay, now we can able to understand that all the cells are connected in series. Okay, so 2, 4, 6, 8, okay, 10, 12. So this battery will give you a 12-volt battery. Okay, so the voltage design of a battery will be by this individual rating of the cells. Now we talk about on the pack. Pack means, everything will be in a plastic pack with the thermal management. Now the battery will be given by two major specifications. Okay, so one is called as your voltage. Okay, so one is called as your voltage and one is called as your AH. Okay, voltage means, I said, how the voltage value are giving. What is meant by AH? AH refers to what is the capacity. Okay, for an example, okay, how much of your current you can able to take from the battery under specified conditions. For an example, if you're using a 100 AH battery means, okay, let us say that you are using a 12-volt 100 AH battery. Now you consider that, you are using the load of 50 ampere load. Okay, 50 ampere load means if you're giving 100 AH, this is called as your load. Okay, and this is called as your battery AH. Okay, so your load is going to be a 50 AH. You're giving from 100 AH battery. So how we can able to calculate means, so this 100 AH battery will power the load of 50 amps for the time of 2 hours. Okay, normally in our house we will be not having the 50 ampere. Okay, let us say that, you're using a 100 AH battery, 100 AH battery. Let us say that in your house you're having only a load of 10 ampere. Okay, so you can able to work with your house for 10 hours. So the battery of 100 AH can power to your house for 10 hours. That is the reason the people, those who are selling the UPS, they will say that, sir, I'm going to give the backup of 8 hours backup. What is 8 hours backup? Because they will be calculating that you are not going to use more than 10 ampere. Like in our house, we are not going to make use, because we are not running an industry. Okay, we are not running an industry, so our loads will be like 10 amps or even less than 10 amps. So while we're going for that 100 AH, so where you can able to get a 10 hours. So for the reducing some losses, reducing some kind of aging of the battery, they will say that 8 hours. So if your house is of 10 ampere and the battery of 100 AH, you can able to power for 8 hours continuously. That is a normal calculation. What we can able to use that ampere hour calculation. That is called AH of your battery. Now, the battery is having some specific energy, which we normally called as the energy density. That is, it will tell you that how much of energy the battery can store for the given weight. Specific power means how much of the power can be stored in this particular battery. Energy density means, it will be given by what is your watt hour per liter of your battery. That's a liter means per unit volume of a battery. And then the power density will be given by what is your weight, the power in watts divided by volume. So I refers to the volume. Now let us talk about what is it meant by internal resistance of a battery. Because internal resistance means, it is the overall resistance that has been provided by the battery. Okay, so that resistance will vary for the different charging and discharging, and also vary with the different operating conditions. For an example, I am also purchasing a battery A, and you are also purchasing the battery B. Okay, both are same specifications. Okay, so my charging will be different, my discharging will be different, and your charging will be different, and your discharging will be different. So this difference is manifested by what is the internal resistance of our batteries. So this internal resistance will be vary based upon the various conditions. Now we talk about on the peak power. As per the United States Advanced Battery Consortium, the peak power of the battery is given by 2 into open circuit voltage square divided by 9 into R. So 9 refers to the internal resistance of the battery. Open circuit voltage means what is the maximum voltage the battery will give when the battery is open circuited. Okay, so whenever the battery is not connected to the load, we will be capturing the open circuit. Okay, so where we can able to understand that. So if it is case, so where we can able to understand that whatever the thing, okay, so we can able to understand the maximum voltage the battery can withstand. So next we talk about on the cutoff voltage. Cutoff voltage means, okay, it is going to be the minimum voltage given by the manufacturer. For an example, let us say that your battery, your mobile phone battery, let us say that your mobile phone are operating with 100% of charge to 0%. You are using your battery and using your mobile phone and reaching to the 0%. Okay. And you what you will do, you have to supposed to stop your talk when the battery reaches 0%. But according to you, it is 0%. But according to the manufacturer, it is not 0%. Okay, there will be some other reserved voltage will be available. Okay, because it is used to protect the battery. According to you, it is 0%, but according to the manufacturer, still some charges will be available. Okay, because a battery will be damaged by two major items. One is overcharging of a battery, and one is called the over discharging of a battery. Overcharging, manufacturer cannot do anything. It is our individual we have to do, because we have to charge the battery only up to 100%. That's all. Okay, if you keep on charging means it is called overcharging, that will damage the battery. Okay, and similarly, over discharging means always using the fullest like that. That is up to 0%, and making the battery to even operate after the 0%, and utilizing the cutoff voltages also means that's called as a over discharge. Okay, so based upon these factors only, we can able to get a complete overview of state of the battery. So what is meant by the state of charge? Okay, so we need to know the definitions for the state of charge. Okay, so the state of charge, we can able to understand that that is it is defined as the remaining capacity of a battery. Okay, so we have to understand what is the remaining capacity available in the battery. Okay, for an example, 100 Ah is the rated capacity, and the remaining capacity is going to be 60 Ah. Okay, so 60 Ah is your remaining capacity divided by 100 capacity. Okay, so where we can able to understand that. Okay, so where we can able to get this particular thing. Okay, so where we can able to understand how we can able to get okay, so how we can able to get the corresponding okay, so corresponding items, so how much our battery will be work. So that's kind of thing. Okay, so this is the very important aspect. Okay, so this is the what we are going to important item you have given to the manufacturer specific and also for the research. Okay, so SOC is a very important thing. What is the remaining capacity divided by rated capacity? Depth of discharge means it will be indicate the percentage of battery that has been discharged, which has been already utilized. So depth of discharge can be calculated by 1 minus state of charge. What is meant by state of health? State of health is given by, that is, what is the health of the battery. So for an example, the rated energy capacity is 100 Ah. Okay, and what is the aged energy capacity? Okay, so based upon that, the state of health is given. Okay, now you can even work in the prediction of these things. Okay, the prediction of these things. But let us talk about the cycle life. That's called as a number of cycles. So it is called as a number of charge discharge cycle of the battery that it can able to withstand. Okay, so for an example, when the battery is given by 5,000 cycles, means it can able to operate for 5,000 cycles. After the end of the 5,000 cycles, the battery will be able to drain. Okay, so where we can able to understand that, it can able to make sure that. Okay, so just a minute, I will come back. Just 1 second, 1 second, just 1 second. Okay, so sorry, I went to drink some water. Sorry. So here we can say that this slide shows that how the charge cycles works. Normally, this is applicable for the battery. Normally, this applicable for the battery. Normally, this applicable for okay. So this particular thing. Okay, so where we can able to understand that how far we can make a charge. For an example, let us talk about bulk stage means, that is whenever you're taking a 12 volt battery, during the bulk stage, the battery will charge up to 14 or 15 volt. During that time, the voltage phasor and the current phasor will be the increasing stage. And after that, the absorption stage, the battery will remain in the voltage of 14 volt for some time. And whereas the current phasor will be the decreasing. And then the flow to stage, what is happening? The voltage phasor is also reducing and the current phasor is also reducing. So whenever you talk about on the charging time, the total charging time is calculated by the time taken for bulk, the time taken for absorption, the time taken for float. So adding all these times only, the time taken for the complete charge. For an example, whenever you're charging a battery from 0% to some 80%, it charges very fast because it is in the bulk stage. Because during the bulk stage, the voltage phasor or the current phasor are the increasing stage. So whenever your battery reaches from 70% to some 85%, it charges very slowly because it is in the absorption stage. What happens in absorption stage? The current phasor in the drooping stage. That is, it is going down. Okay, so and then whenever you are going to charge your battery from 85% to 100%, what is happening? It takes more time because we can say that the voltage phasor is also reducing and current phasor is also reducing. So because of this, we can able to understand that how the charging takes place in a battery. It applicable for all the kind of battery. Let us take a charging profile of a lithium-ion battery. So here we can able to say that how about this shows the variation between your battery voltage and also the battery charge current. Okay, so how about how the charges it starts. Okay, so this is called as your pre-charge interval. So from here the charging takes place. So the charging can be made either by the constant current charge or constant voltage charge. Okay, so initially it goes with the constant current charge and then leads with the constant voltage charge, and here the charges will get complete. So this will be the time taken by the battery to get charged. And finally, for the recharge or the charge complete, it depends upon how much the battery is going to be get consumed. So this is one of the EV charging schemes. Okay, so let us say that this is going to be the, as per the IEEE standard, the electric power utility. It is given to the service equipment and branch circuits, and this is called as a electric vehicle charging infrastructure. So where we are getting some connector, and this connector is connected to the port. Okay, either we got called as a AC charge port, or else if you're having a DC charge port, it is available over here. So since it is going to be AC electrical energy, we are going to connect it to the AC port. Okay, so once it reaches to the AC port, what is happening? It is going to be a converter, a power electronic converter, which converts your AC to DC, and then it is given to the battery pack. So in this particular battery pack, we'll be having the battery management system. Okay, that's what earlier cases, we normally give memes for the battery management system. Battery is like a Bahubali. Battery is like a Bahubali. Okay, where it's miniature, a small of its weapon is called as a battery management system. Battery management system is not a very big as like a Bahubali. It's just a small piece of equipment which is helps to control or monitor the battery. That's all. That's called the battery management system. Whereas we have to focus much on the battery. This battery management system is only a supervisor, and then from the battery we'll be connected to the power electronics to convert your DC to AC, and then we are connected to the AC motor, and then we are connected to this transmission medium, so which will help us to make the drive to rotate. So here this block diagram is a generalized block diagram how the energy transfer takes place as per the IEEE standards. Okay, but the thing is that there are more and more kind of works can be done with the machine learning. Okay, so how the machine learning will help in this EV charging infrastructure means, you can determine what is the charge remaining in the battery. You can even work with the battery management system with the machine learning. You can even control the power electronics with the machine learning. You can control the motor with the machine learning. You can able to predict the faults. Okay, this is the area what I'm working with. Okay, detection of faults in the EV infrastructure using machine learning kind of. So this is a typical charging level of an EV. So level 1 one charging means, up to 3 kilowatt. Level 2 means up to 20 kilowatt. Level 3 means 40 kilowatt and up. So normally, whenever you're going for the car, that we have made a power calculation. Those power calculations are more than 40 kilowatts. So we normally make use of the level 3 charging level. So this I will skip the V2G and G2V, and these are some of the electrical vehicles that has been in this Tesla Motors, and electrical designs of electrical machines, kind of. Okay, so by this I just completed this electrical vehicle infrastructure. Now, if you have any questions, I can see there are no questions in that chat box. If you have any questions, we can able to put to the chat box. Now we are going across for the next part. Okay. Actually, this is going to be my first part of this today's session, but this is my thing. But unfortunately, what you can see, this my presentation consisting of how many slides you see? 252. Okay. Fortunately or unfortunately, it is not possible to complete within next 30 minutes. You see, 252 slides, which all prepared by me for the entire machine learning algorithms. Okay. But in accordance to the syllabus of our course, I'll explain you how this machine learning will help us for the complete control, because this FDP is on the mRuby. Okay, it is one of the decision-making control tool. So based upon that, we can able to understand this particular thing. Okay, so in this particular case, okay, where we can able to understand this thing. So here, let us talk about on the machine learning. Before we are going for the machine learning, I want to tell you that I am an electrical engineer. I am an electrical engineer. Okay. But for the past 15 years, I am handling the subject called deep learning, AI. I am handling the subject on machine. Even the VIT, the previous semester and this semester, I'm handling the subject on machine learning only. Okay. So this is my profile, because, many a times the people will say that, and you should also consider that, even the people, those who are completing the computer science, okay, I can even challenge to them that, the machine learning, what the person from electrical teaches, okay, will not be compared with the people, those who are from the computer science, they will teach. Okay. Because I want to tell you one major thing. This machine learning and deep learning techniques are first developed by electrical engineers only. If this information is known to everyone, then we can say that electrical engineering will be getting full admissions across the country. But what everybody made, this machine learning is a coding. So coding means it is applicable to computer science. So in that way, these electrical people, they made a very big sacrifice. That is, machine learning will be taught by only the computer science people, not by electrical people. So that is the reason what happened. Everybody went to artificial intelligence, data science, and those courses, and the admissions for the electrical is still in the hanging. Okay. But nobody is having that kind of exposure that, this machine learning models are initially developed by electrical engineers. Even some algorithms in machine learning are developed based on Ohm's law. Okay. I will explain that one, how the Ohm's, based on Ohm's law, how they developed an algorithm. I will explain you now. So, and even we say that, we are the initially start the coding with the microprocessors, because for the control application, we need to write the program in the microprocessor and the microcontroller and the FPGA processor and all. That is what needed for the real-time applications. For interfacing a stepper motor, for a 7-segment display, and control of a printer, for those things comes under the syllabus of electrical only. Okay, and even the sensors and transducers, and capturing the sensors, and through the sensors tuning the control of PID, all the real-time applications are with the electrical engineering. But finally, what happened? No persons to guide the people of electrical engineering, and now it was deviated that all the coding and everything is with the computer science, and the people, those who are teaching there in the machine learning and deep learning, they create the models and do And even the people, those who are studying, they study something like a deep learning or cloud computing or something like that, and finally they get placed on something, they work in only Excel sheets. But the realistic machine learning is totally a different picture. It is just like a fantasy movie. Okay, that's what I teach this machine learning for electrical engineers. I teach for the chemical engineers. For the core people only, I used to teach. I will not teach for the computer science people because they already keep in their mind that they are the very big coders. In the last 2 years, I published the papers in machine learning, nearly 40 papers I published in machine learning with the various models. Only the Q1, Q2 journals in IEEE kind of. How it is all happening, even as an electrical engineer. The thing is that we should take the initiation for the machine learning. Okay, that is what I want to give a takeaway message for the today's session. The last session I given how the electric vehicle we can rule, how it was a very old story, how we are just taking the old lamp and cleaning the old lamp. That's what the takeaway message in my Tuesday session. Today, my takeaway message for every participants over here is electrical engineers should rule because we are the pioneers on machine learning. So when we talk about on the artificial intelligence, what we are doing, we are just making a controller to think as a human being. That's all. It's a one-line story. That's called AI. Under this AI, what we are going to do, we are going to develop some algorithms. So these algorithms, what they will do, they will learn from data. That's all. Okay. What is the input for this machine learning? The data. Once you, I will challenge you. If you give your data, your work in machine learning is 95% over. Okay, the remaining 5% is just coding. That's all. Okay, for an example, if you are giving your data set by today, for an example, if you are giving your data set for at 7:30 p.m., at 8 p.m., I will develop and give you a model. That's all. So that is the reason that people are working with the data science. That's all. They want to cook up the data. They want to capture the data. They want to take the data. That's all. So that is what the thing happening in the machine learning. So if you have the data, 95% of work is over. Other work and all, nothing. So what the people they are doing, their one website is their kaggle.com or github.com. They will download the data from here. Okay. What happened? Their 95% work is over. Okay. And they will download this machine learning algorithms in one more thing at using a chat GPT. They combine this work and this work. 95% of work is also over. 5% of the programming work is over, and they will collect the results and they beautifully publish a paper. But you take any of my papers, all the data set was ready by us, developed by us. We generate our own data set. We never ever download the data from the internet. For an example, for the battery management system is concerned, we take a real-time data from the battery, and from the battery, we will be assessing and analyzing the parameters. Okay. So that is called the machine learning. So it's a very simple. So if you have a data, you create a model. Why we are calling as a model? Okay, we talk those things as a model. What is meant by a model? So model means, that is, for an example, if you want to use a shampoo, you see some advertisements. So the people, those who act in the advertisement, we call them as a model. Okay, so we say that they are doing the modeling. That is, they are not a real. They are not at all real. They are not at all real. We don't know whether they use the shampoo, whether they use the soap in which they are advertising, but they are all a model. They saw that by using the soap, I got this glow in my face. By using the shampoo, I got a very good hair. They are all models. They are not reals. The same thing happening in the machine learning. So using the data, what we are going to do, we are developing a model. Now the model is like a box. Okay. Now the model is like a box. That's all. You created a model. As I already mentioned you how to create a model, take the data set and write one algorithm for the data, and then you just make one program model that the model is created. Now, very simply, how will you define the machine learning means? You know the present data. That is today what happened to the battery, Okay. You know the past data. What happened to the battery, So because tomorrow what is happening, you don't know. Okay, because you cannot be able to see what is happening to tomorrow. You have the today data, you have the yesterday data, you that is you are having the present data, you are having the past data. Making use of this, you created a model that is using the present and past. Now the model is ready. Okay, so now tomorrow you are giving some data as an input, that is called the future data, that is for tomorrow. Okay, so this is a tomorrow, this is a tomorrow. So what is the tomorrow data? When it reaches the model, it will oversee what happened today, what happened yesterday. So based upon that, it will produce an output. That is called machine learning. Okay, machine learning is defined as, okay, making use of the present data and past data, how you are predicting the future. That's called machine learning. But many people, what they are confusing about the machine learning, what they will do, they use the data and they will show, sir, this data is monitoring, this data is calculating. Those things is not at all machine learning. We need to know what is the clear basics of everything. The basic fundamental of machine learning is, for an example, you know your health data for today. You know the health data of today. You know your health data of yesterday. Based upon that, you create a model. Based upon that, you create a model. So now you created a model. So based upon the model, tomorrow you are giving your blood samples or BP to this model. Based upon that, it has to predict that what kind of disease you have. That's called machine learning. For an example, you're taking a battery. You're taking a battery. In this battery, you are collecting your present data. That's a normal data or a fault data. Everything you're having. Yesterday, normal or fault you are taking. Yes, tomorrow you are giving some abnormal data. So the output, what it will give you, the battery is going to get damaged. That is called prediction. We are going to predict the future. That is called machine learning. So we are going to make use of the algorithms. That algorithms, what it will do, it will gain some intelligence based upon the data. Okay, how the machine learning is gaining the intelligence based upon the data. That is the reason the people, they are studying one full course on data science. If your data is ready, you can make a machine learning model perfect intelligence. If the data is not good ready, okay, what will happen? Then you can not able to get a very good intelligence. Now the people, they even work on the deep learning models. What is deep learning? Deep learning will be called as the, okay, so deep learning will be called as the another segment, okay, another segment where you can able to understand that, with this segment, you can able to incorporate much more intelligence to the machine. That's called deep learning. Okay, so this is what we have already discussed. Okay, so the way how the human brain works. Okay, this is quite a history of this intelligence. Actually, this intelligence was started in the 1943. Okay, the whatever the names I'm giving over here, they are from the physics. They are from electrical. Okay, they are from electronics. Okay, so they have developed these algorithms. For an example, in 1960, a network was created called Adeline. So this network was created based on the Ohm's law. Based on the Ohm's law. So how the Ohm's law works, we know that voltage is equal to I into R, but actually this is not a Ohm's law. You have to write the Ohm's law as V is equal to Ri. This is correct. This is wrong. Okay, so V is equal to R into I. For an example, you are giving some set of voltage as an input. You are experiencing a current at the output. So based upon that, you are varying the value of resistance. Okay, so here also in Adeline, what they did, so they are giving some inputs and they are going to have some outputs. So in order to balance your input and output, they just varied the value of resistance. So even the Adeline is an abbreviation which is called as an adaptive linear element, because we know Ohm's law is going to be this V is equal to IR is a linear equation. Okay, and then in the 1972, coherent self-organizing future map, back propagation, radial basis networks. So the history just it travels. Okay, so something like in the 50 to 60 years, this has propagated to a very large base. When we talk about on the algorithms, so we can see there are n number of algorithms are available for the control and also for the conditioning of the battery and also for the EV technology. For an example, this kind of learning can be classified into two types. One is called as unsupervised and one is called as supervised. So there are two different type of networks can be done. One is called as a feedback network, one is called the feed forward network. These are the different algorithms. So what I made for one of my research college, so he came with one research problem. Okay, he came with one research problem. Let us say that he came with a power quality research problem. I asked him to apply all these algorithms. I listed out only the important algorithms. Okay, important algorithms. Okay, so he worked with all the algorithms and made a comparison of all the algorithms for one research problem. And then he made a comparative analysis and found the paper, and that paper is also got published. Okay, so this is the way how we need to learn about this. So normally the people from power electronics and power system, we normally use a supervised learning. That is, the input, for this input what kind of output will occur. What is the perfect target. Then it is called a supervised network. So normally we use the feed forward networks, which will be started as a journey like these are the algorithms. You can ask the question. So what is meant by this algorithm? Algorithm means it is a step-by-step procedure to accomplish a task. And here, what is going to be the task? For an example, if you're giving 0, 0 as an input, the output is going to be a 0, or 0, 1 means it should be a 0. So as a human being, you can be able to learn that 0, 0 is equal to 0 and 0, 1 is also equal to 0, whereas for 1, 1 is equal to 1. As a human being, we can learn. As a human being, we can learn, but we want to make a machine to learn. So here the task is going to be how we are going to make an algorithm to remember whenever the 0, 0 comes, it should give the 0. 1, 1 comes, should go give us a 1. So that is the task. So to accomplish the task, we need some step-by-step procedure that will be accomplished by this algorithms. So now this is the basic algorithm in the machine learning. Okay, so in this presentation, I'm going to show the variety of algorithms are available. So this is a very fundamental algorithm. For an example, I'm giving some inputs like 1, 2, 3. Okay, so here what will happen? Let us say that how the algorithm works. I'm giving some 1, 2, 3, and this is going to be a bias is also 1. So now what is happening? It is going to get summation. Okay, let us say that I'm going to add some weights. Let us say these are called as my weights. What is meant by weights? As I already mentioned you, as per the Ohm's law, you are going to vary the resistance. As like resistance, here I call the word called the weights. So what is the summation over here? So 1 into 1, 1 plus 1 into 1, 1 plus 2 into 1, 2 plus 3 into 1, 3. So totally the summation, what will happen? So that is called the here. So Xi, Wi. So these are called as a Xi and this is called as a Wi. So summation is equal to 3 plus 2, 5, 6, 7. So I get the value as 7. I got the value as 7. And after the 7, I want to give to this network. This is called as the squashing network. Okay, or it is also called as the functions. Okay, which we normally call as a identity functions or squashing functions. What this person will do, it will convert the 7 into either 0 or 1, or it will convert or 0 or minus 1 to plus 1. So when it converts the 7 into 0 to 1, I call as a binary. When it converts the 7 into minus 1 or plus 1, I call it as a bipolar. Okay, so this I call it as a transfer function. Okay, so in this algorithm, what is happening? It just multiplies my input with the weights and gives a value, and then my value will be scaled down, which will be normally called as a activation function, or I call it as a transfer function. Now what will happen? I will convert the 7 into 0 to 1 or minus 1 to plus 1. You can ask a question, sir, how the 7 will be converted? We will be using some formulas like 1 divided by 1 plus exponential of minus x. So you just substitute 1 divided by 1 plus exponential of minus 7. You will be getting some value. Let us say that I'm getting the value as 0.6. Let us assume. So now what will happen at the output? You will be getting the value as 0.6. Okay. Now this is the condition in the perceptron. You will be checking that when the value is equal to 1. Okay. For an example, when Xi Wi is greater than 0. For an example, here the summation is equal to 7. Okay, 7. Since the value 7 is greater than 0, you assign the output as 1. Okay. When since it is greater than 0, you are assigning as 1. If it is otherwise, you assign minus 1. That is the algorithm of perceptron. So here, the numerically, we can able to understand that, for an example, I'm giving some 3 inputs. I'm going to give some weights. I'm going to give some target.
So based upon this, I will be updating the weights until I get the target. Okay, so these are called as my input, these are called as my weights, and this is called as my target. So until I am getting some sufficient weights, okay, what I will do, I will update the weights. So updating of weights are called as the algorithms. So I've given you the list of various algorithms here. I've given the various algorithms here. What is the role of these algorithms? So these algorithms will do the updating of weights. The one and only work, what it will do, it will update the weights. It will keep on updating the weights. That's the thing. So up to what time it will update the weights? Until you get the target. So for updating the weights under this algorithm, we are having this formula. So this is a formula is used to update the weights because the initial weights is not giving the correct answer. So I want to change the weights. So I want to use a new weights. So the new weight will be equal to what is the old weight plus the learning rate. What is your requirement? What is your output you're getting? Multiplied by your input, you will get the new weights. So you check whether your output you are getting the target or not. If get target, okay. If you're achieved, okay. That means you leave it. If not, you can go. So the time taken until you achieve the target, we normally call as a computational time. Okay. Computational time means, the time taken by your controller to achieve your task. Till what time you're achieving your task. So based upon this, I will explain you how a simple network is learning. Okay, so by this you can able to understand that how a simple network is learning. Okay, so I will stop the session for 2 minutes for your general queries. If you have queries, you please put in the chat box. So after you put in the chat box, I will again come and I will solve the problem. Please excuse me for the just 2 minutes. I'll drink water. So if you have any queries till now, you please put in the chat box.
Okay. Dear participants, if you have any query, please put in the chat box.
Okay, thank you. So I will answer this question by Shubharao sir. So after this small exercise, okay, surely I will answer. Okay. So here you can able to see, I want to have a data like this. Let us say that I'm going to take a AND. So AND gate means that 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, 1, 1 is 0. These are called as my input and these are called as my output. Okay. For an example, you come across a battery data. Battery data. So for battery data, let us say that you're going to take the input and output. Let us say that input, I'm going to take the voltage and current, and sufficiently, I'm going to take the SOC. A real-time data. For an example, I'm taking the 6 volt and I'm going to take the current as something like a 3 amps. SOC is 0.6 and 8 volt and current is equal to 6 amps and then the SOC is equal to 0.5. So like this. So you just, I'm explaining the AND gate. You just imagine how it works for the battery. Similarly, as per Shubharao sir message, how to get the battery data. See, I will tell you 5 steps how to cook up the data of our own. 5 methods after this exercise. Okay, so you follow any of the 5 methods, okay, to get the data, real-time data. 5 methods. Okay, that method will never ever be downloaded by the internet because the data that is available by the internet will be it's just like the people those who are done for their work were collected for their wish. But whenever we are going to do a proper research, the data should be of the realistic one. So now let us say that, initially I'm taking the weights as 1.2 and 0.6 and threshold is equal to 1. That is threshold is equal to 1 and then alpha is equal to 0.5. Okay. So this is the initial way how my network says. Now I'm going to explain you how my network is learning. You take the first data set. This is a first data. I'm going to explain you how the data set learns. So here you can able to understand input 0, 0 means output is equal to 0. So as per the perceptron, I want to multiply the xi, wi. That is, what is the xi? Xi is the input. Okay. What is the w1 weight is 1.2. And what is your next input? And what is your next weight? So I'm getting the values 0. Here your fixed threshold is equal to 1. Okay. Now the output 0. So the output 0 is lesser than the threshold. Okay. So let us say that the output is lesser than the threshold. So what I'm going to give, instead of -1, I'm going to give it as a 0, because this work is a binary work. So it's not a bipolar work. So now what I'm going to do, this wixi is lesser than 0. So what I'm going to do, I'm going to give the value as 0. Okay. I'm going to give the value as 0. So fortunately, unfortunately, what is happening when the 0, 0 is, the output is also equal to 0. So the first data set, it learns very accurately. The first data set, it learns very accurately. Okay. This is the way how a single data is getting learned. This is the way how a single data is learned initially. Okay. So where we can able to understand that, how a single data is learned. So this is the way how we are going to understand okay. So where we can able to understand that how we are going to make a thing. Now let us talk about for the second data set. The input is going to be 0, 1. That is your input, and the target is equal to 0. Okay. So 0, 1, the target is equal to 0. Okay. That is your second data set. I want the data set to be learned. Again, you use the formula xi, wi. So x is equal to 0, and x1 is equal to 0, and x2 is equal to 1, and the weights, initial weights are 1.2 and 0.6. You are getting the output as 0.6. Again, you can see that this 0.6 is lesser than your threshold, so the output is equal to 0. Output is equal to 0. So the two data set is learned very perfectly. So it is going in a very good way. Now we are going for the third data set. What is the third data set? Whenever the input is 1 and input is 0, the output is equal to 0. Okay. Now what I'm going to do, xi w1 and x2 w2, you're getting the answer as 1.2. Now what is happening, this xi wi, when it is greater than my threshold theta, I want to assign the value as 1. So you are going to assign the value as 1. But fortunately, what is happening, you need to get the answer as 0. But now you're getting the answer as 1. There comes the target is not matching. So up to the first two data, it was learning in a very good way. Okay. Up to the first two data, it was learning very good way. But when it comes to the third, okay, when it comes to the third data set, it is not able to learn. This is how the machine learning works. Okay, how the learning, how the training of the data is going on. Okay, how the training of the data is going on means like this only. We'll be having a couple of data and we'll be comparing with the data, and then we check whether we are attaining or not. Now what is happening? It is the third data set is not happening. So now what is the solution? So initially we have taken the weights as 1.2 and 0.6. So this 1.2 and 0.6, these weights are very good for my first data and second data, but for the third data, it is not valid. It's not at all using. So what I have to do, you have to tune this data. So tuning of this data set is called as machine learning algorithms. Okay. What is called as algorithms? Algorithms are called as tuning. What you want to tune, these values you want to tune. Now what is happening, this 1.2 and 0.6, they are called as my old data now, because these old peoples are not giving the good answer. So I'm throwing the old ones. I want to take the new data. So how to calculate the new data? Because I'm working with the perceptron algorithm. So in this perceptron algorithm, what is happening? You are taking the new data, which is equal to, formula is equal to what is your old data plus alpha is your learning rate. What is your expectation of this third data? You are expecting a 0, but what the expecting is 0, but what actually is coming is 1. Okay, so that's the thing. So what is your old weight is 1.2. Here I'm taking the alpha is equal to 0.5. So learning rate is a value between 0 to 1. Most of the IEEE papers, they used to take 0.6, 0.7. So here for this case study, I'm given as a 0.5. So what is the desired value? You want 0, but coming is 1. multiplied by what is the input for this case? 1. So now what happened? You are getting the value is 0.7. Similarly, for the next W2, one is 1.2, second one is 0.6. You take this 0.6, okay, second data. What is your alpha? What is the value you're getting? What is your actual and what is your input? 0.7. Now, what happened? The old weights are 1.2 and 0.6. Now, the old weights are now changed to 0.7 and 0.6. So, they are called as a new weights. So, this is called as a transformation. Since the old weights is unable to accomplish the task, since the old weights, they are not able to accomplish the task, now I shifted the thing. So who is doing this task? That is done by the algorithm. That is called as a machine learning algorithms. What is the one and only role of a machine learning algorithms? It will change, it will tune. Okay, it will tune whether the data is working or not, whether the data is functioning good or not. So that's what it will be learning. That's what it will be learning. Okay, so once it learns appropriately, okay, okay, now I got the next one. Now what happened? You should not start the work from third data. Okay, now you should not start the work from third data. Okay, you should again start the work from the beginning. Okay, so you have to go with the data set number 1. What is data set number 1? 0, 0 is equal to 0. So now you're going to work with the new data, new weights. That's the new weights are 0.7 and 0.6. So 0 into 0.7 plus 0 into 0.6, 0. Threshold is less than 0. So the output is also 0. Correct. So the new weights is also good for first data. First data is correct. Second data. So inputs are 0, 1. The target is equal to 0. So 0 into the new 0.7, 1 into new 0.6, you're getting 0.6. So 0.6 is less than your threshold. So the output is equal to 0. For this also it is working. So third data set means, so you're going to multiply. You're getting the answer as 0.7. Okay, so 0.7 is less than 1. Okay, so you're getting the output is equal. Since 0.7 is less than 1, for third data set it's working good. For third data set is also, it is working good. Now you come back to the fourth data for the AND gate. So 1, 1, your target is equal to 1. So for the 1 into 0.7 and 1 into 0.6, you are getting the greater than 1.3. So this 1.3 value is greater than your threshold. Since it is greater than threshold, you have to give the value as 1. Obviously, the output is also equal to 1. So now the target is same as the calculated output. So for performing your AND gate, okay, so the final weights are equal to 0.7 and 0.6. Okay, so when you are working with your AND gate with a 0.7 and 0.6, okay, what will happen? Whenever if you train the machine with the weights of 0.7 and 0.6, whenever you're asking the machine what is 0, 0, it will give 0. What is 0, 1, it will give 0. What is 1, 0, it will give 0. What is 1, 1, it will give 1. That's it. Similarly, for the battery management systems, you give the inputs, it will produce the outputs. Now, sir has asked me a doubt, okay, related to how we are going to collect the data sets. I will tell you, there are 5 methods are available to collect the data set of a battery. First and foremost method, you simulate the battery, what you're going to work in a simulation medium, and change the parameters, either the input side charging parameters or change the load parameters and collect the data. That's the first step. And people, they will say, sir, I cannot able to simulate, sir. Okay, there is no time for me to simulate. So for that, what you have to do, you can be able to make a real hardware of a battery, and then you take either the voltmeter or ammeter or a clamp meter, and then vary the input and vary the output from the hardware. You can collect the data. Second method. Third method is very important method, MM method. What is MM? That is called mathematical modeling. Okay, many people are not interested in the mathematical modeling. The only mathematical modeling what people have done while they are studying the subject called control systems. While they're studying the subject called control systems, at that time only the people studied about the mathematical modeling. Okay, they did some mathematical modeling of armature control DC motor, the field control DC motor. But whatever the work you are doing, we have to derive the transfer function. That is the basic concept of the process control. And even the people from chemical engineering, Okay, they want the people only from the mathematical modeling. For example, for the chemical plant, each and every day we cannot be able to go and check the chemical plant. So we want to make the entire chemical plant in the form of equations. So you want to change some parameters of the chemical plant. You cannot be able to go and change the chemical plant because it's very hazardous. So whatever the change you are interested to do for the chemical plant, you can change. You can change in the equations itself. While you're making the equations itself, while you're making the equations itself, you can analyze what kind of changes you can able to see in the particular thing. Okay, so that is very important, the mathematical modeling. Next one is fourth method. Fourth method is, okay, by making use of the formula. Okay, by making use of the formula. Okay, by making use of the formula. Okay, so how we are going to devise a formula for your entire system. Okay, so where we can able to understand that, for example, when the control system teacher come or the mathematics teacher, he comes and solves for the linear algebraic equation x square plus y square is equal to 20 and y square plus z square is equal to 14. Find the value of x, y, z. They will ask the question. Okay, so while they're asking this x, y, z, we don't know what is meant by x, what is meant by y, but we should know that each and everything defines a system. So we have to derive the formula. So my PhD work and postdoc work, I created the data set by using the fourth method, by deriving the formula, because I worked in the inverter segment. So I made use of this particular kind of Fourier transform equations. By the help of the Fourier transform equation, I made the particular formula, and from the formula, by changing the input and output parameters, I collected the data. So where we can able to understand that, by using this particular data, okay, I made the work. These are the four methods how you can able to collect the data. Fifth method is, okay, this is through internet only, but I recommend you can able to download the data at IEEE data port, not by any other things. It's just like a IEEE data port. So here you can able to click the link. If the data is available, you can download from the IEEE. For this, you need to be a member of IEEE. And if you find difficult to collect the data from the IEEE data port, so if you have any doubt, or if you want the data set to be downloaded, you can ask me. I can able to download and give you. These are the 5 methods by which you can able to collect the data. Okay, but you can ask a question, sir, how many data to be collected? Even if you have 10 data in your hand, you can develop a perfect model. Many people will say that, sir, I'm having 10,000 data, so my model is good. No, even if you're having less than 10, you can develop a very great model. The numbers of data does not brings a very big difference. Limited data, training the data, and how you are making with a limited data, how you are making a system a perfect, that makes a real sense. So I hope I answered, and I hope that's quite the thing. The next 5 minutes we'll be having some queries, and we can able to end the session. That's what Kaggle.site is, that is, that's also the people they have downloaded, they have made for their system. Okay. Now many of the research papers, they are working with the Kaggle.com only, but I prefer not to go with the Kaggle. Okay. The thing is that, the Kaggle is made for their battery specification, their loading conditions. But for making some conference paper or a research paper, that is quite well okay. But for the detailed analysis, because I said, 95% of the work, 95% of the work will be on how we cook up the data, how we are designing the data, how we are making the data. The rest of the next 5% is only our contribution. That's all. Our writing a coding. Writing a coding is very easy with the Python. And even many people are not at all writing the coding. They just download from ChatGPT. But I ask my scholars, because I usually ask the questions from the scholars to explain each and every line of the codings. So they should write on their own. Until unless they don't know the coding, they cannot be able to satisfy me. So they will become a real experts when they write the coding of their own. Any queries? Because I think the next session will start at 7:30. Yesterday, I don't know that. So
Any questions from participants, sir?
So even if you want to have any kind of collaborations with respect to paper publications or projects, or if you need any kind of collaboration works which you are interested to work with, I'm very happy, and I'm very happy to associate with the peoples, those who want to travel in the real technical field. So you can contact me through email or in the WhatsApp. Okay. So how do we get the alpha value? So alpha value is an assumption. Okay. So this assumption value will not make a very great essence. The thing is that, the alpha value will be the assumption. Okay. So whose range is between 0 to 10. Okay. It is just like a catalyst. It will not make any changes in our data. Rather than that, it will be very helpful to stimulator. It's just a stimulator. This alpha value, because we have made a analysis with the various IEEE papers, most of the IEEE papers, they take alpha values between 0.6 or 0.7. That's all. You can even refer my papers that has been available in this machine learning. So we normally set some targets for publications as well. So every year we'll be making some like 50 papers. That is the usual target which we normally keep. I normally keep. Nobody asked me to do that one, but I normally keep the number of papers in the SEA journals to be 50 per year. Okay, but we cannot able to achieve that one. But normally we'll achieve up to 30 or 35. Okay, so that's the thing. If anybody interested to collaboration, okay, for this electrical domain, you are mostly welcome. So thank you so much. Now the time is 7:30. Okay, I can end. So this will make the other speaker to continue the session.
Thank you, sir. Thank you for your insightful presentation, sir.
Thank you all. Thank you so much.
Thank you, sir.
Thanks.
Now I call upon Ms. Silambarasi to give an intro about our next speaker, Christo Anand, sir.
Very good evening to all. Now we'll head over to next session. For this session, I'm going to read the profile about the resource person, Mr. Christo Anand. He is currently serving as a professor. He got his BE degree in Electronics and Communication Engineering in 2009 and his ME degree in Applied Electronics in 2013. He received a PhD degree in engineering in 2017. He completed his postdoctoral research work in cooperative networks in 2018. Christo Anand has almost spent a decade in research in instructing, counseling, and down to earth application improvement. His exploration skill covers image processing, cooperative networks, electromagnetic fields, electronic device, wireless networks, and medical electronics. He has taken an interest and presented 3 papers in National Level Technical Symposium, 9 research papers in National Level Conference, 31 research papers in International Level Conference, 90 research papers in referred and indexed international journals in the field of embedded system, networking, digital image processing, network security, and VLSI. He has 15 patents to credit out of which 8 has been granted and 7 has been published. 7 has been published. He is serving as an editorial board member or reviewer of 381 SCI or ISC's corpus or Web of Science indexed international journals and 155 referred, indexed and reputed international journals. He has set up about 87 MOUs as chief with educational institution over the globe. He is chosen as an elected fellow from ISCC Malaysia and a life member from ISTE India. Now I hand over the session to the resource person, Mr. Christo Anand, to start the event about optimizing power consumption and enhancing battery life.
Thank you, ma'am, for your brief introduction. I think let us start the session first of all. So, first of all, let me thank the management for giving me the opportunity to improvise your skills, your knowledge about the efficiency, optimizing the workflow of power consumption, and enhancing the battery life. So, let me go straight to the presentation. So, is my screen visible to you? Is my screen visible to you?
Yes, sir. The screen is visible, sir.
Okay, great. Fine. So we'll start off with the presentation. So optimizing power consumption and enhancing battery life. Let me tell you in the beginning that it is a very light-hearted presentation. Okay.
அப்பா தாண்டி கால் பண்ணிருக்காரு 5
So
மினிட்ஸ் முன்னாடி.
probably you will have a basic understanding of how you can optimize the flow. Okay. Of course, it is especially for you, my dear faculty members, students, and young researchers, and you can reach me at my email ID. Right. So before beginning the session, let me thank God for giving me this opportunity to deliver this useful session, to share my knowledge among my fellow national, international participants and young researchers. So we'll have a short introduction. We'll try to understand why we should actually save energy, what are the various energy saving methods, what are the various components designed to reduce energy consumption, controlling the power supply of individual device components, what are the various smart operating modes, energy efficient data transfer, how you will make it much more faster and at the same time make it much more energy efficient. Okay, so then we'll go for temperature control. So here in the session, we'll try to create a battery budget. Okay, setting of input output to the low power, the starting point for general purpose input output settings. Okay, use processor power modes, how you try to control external peripheral power, optimize the program flow, increase the clock speed to finish processing much more faster. Okay, and at the end we'll try to use a buck converter or maybe a low dropout linear regulator, try to compare the buck as well as the LDO efficiency. So at regular intervals I'll be showing you some short videos to keep you entertained about the importance about this particular topic. Okay, so everywhere we are dependent on battery powered devices. So everywhere, if you try to see, no more people are more interested in petrol and diesel. Yeah, they are much more interested in EV batteries, cars. Okay, right. So we have remote controls, we have sensors, we also have smartphones to guide us. Okay, also we have laptops, even electric cars even. Okay, so energy consumption, the optimization has played a very good key role. Okay, so everything, it's all about like extending the battery life. So how you can conserve, how you can preserve, how you can save for the future. Okay, so let it be a end user, a designer, or a researcher. So everywhere you are going to optimize the energy consumption of battery powered devices. Okay, right. So here you're going to save the energy in a battery powered equipment. Okay, so first of all, it all deals about how you're going to increase the performance and at what ease. Okay, so for example, let us take in the case of a laptop. The longer the battery, along the meter, maybe any electronic device. So how much is going to hold charge? Okay. So naturally, everybody will be using that particular device without any particular problems. You need not have to recharge. Okay. For example, let us take in the case of your smartphone. So maybe you are using your smartphone maybe for a period of a maximum of 2 years, 3 years. Okay, so probably if you are using the maximum totally, it might be 4 years. Let us take in the case of a laptop. Okay. So maybe like 7 years average, on an average, 10 years. Suppose if you are light handedly using. Okay. So it not only makes our lives easier, but also you are going to make sure that the work is continuous. Okay. Where the electric power sources actually limited. Okay. Right. So that's the reason we tend to save the energy. Okay. So we have like service technicians or maybe installers who try to work in this particular field. So maybe they do not have access to the main power supply. Okay. So second thing, it's a very in the financial point of view, you are going to go for significant cost savings. Okay. So the cost associated with the recharging batteries, even like powering equipment, even can be much more significant. So that can be aiding to or maybe supporting to long-term savings even. Okay. So that involves the cost of purchasing new standard, or maybe you are setting up some standards, useful standards for rechargeable batteries. Okay. So here it is not only about conserving energy, it is not only about saving energy, but at the same time, it is you are going towards a greener environment. Okay. So environmental protection is also is a issue over here. Okay. So try to save the energy. It's related to the carbon footprint. Okay. So the lesser the energy they are going to actually consume, definitely the CO2 emissions will be much more lesser, and it might lesser adversely impact the environment situations. Okay. So here the proper disposal of spent parcels that can be no longer recharged is very, very important over here. So there are several methods where you can go for effective reduction of energy. Okay. So here we are going to optimize electronic components, use cost-effective communication protocols, temperature control, smart power management, adjusting operating modes, and using modular solutions. Of course, nowadays, like the masters, the doctoral candidates are working more towards energy saving methods in these research topics. Thankfully, several papers are coming out with energy saving schemes. Okay. So it's very, very important even for company designers, manufacturers, and users to cooperate for a more efficient energy use. And of course, you can extend the battery life. Okay. So we have like battery technologies, for example, Saudi Arabia, Kuwait, Oman, they are more concentrating towards lithium based technologies. Okay. Mechanically rechargeable zinc technology. Okay. So nowadays, everybody are going for EVs, electric vehicles. So we tend to compare the performance, okay, in terms of lithium as well as mechanically rechargeable zinc air technologies. Okay, right. So there are several methods to improve energy efficiency. Okay, every small step, every single step can make a very big difference, both for the users as well as for the environment. Okay, so the ICs, the electronic components, they are growing. Maybe we are going for several microchip technologies. Everything is conservating towards effective energy management in the mobile smart devices. Okay. So that is where both integrated circuits as well as microprocessors are designed with minimization of energy consumption. Okay. So here, make sure that they try to adapt it to the global scenario. So that is one key feature that you can identify to reduce energy consumption. Okay. So there are several microprocessors. They come out with built-in power saving mechanisms to reduce clock rate or try to enter the deep sleep mode when this extensive computing resources are not actually required. Okay. Nowadays, like processors are able to adapt their performance to the specific situation. So we are actually comparing this towards saving energy, okay, during less resource intensive operations. Okay. So there are several setups, settings even, okay. We can carefully observe the output performance. Okay. You're going to translate into energy savings. Okay. So everything you are going to observe how much energy is being carried over in the background. Okay. Or maybe whether it is capable of handling lighter loads. Okay. But what impact does it make on the users, that you should observe into. Okay. So there are several components designed to reduce energy consumption. Okay. So we have state of art technologies, electronic components, energy saving features in battery powered devices even. Okay, so that makes much more a truly effective mechanism in order to go for an in-depth understanding as well as configuration skills for measuring towards the target application. Okay, so here now we are going to go for optimizing energy consumption in mobile devices. Let us take in the case of a smart home. Okay, so we have air filtration, ventilation. Okay, we have solar panels. We have roof wall insulation. Okay, HVAC system, heat pump, water heater. Okay, energy saving appliances. Okay, like a fan, air conditioner, and so on. Sustainable materials, energy efficient natural lighting, okay, water efficiency, conservation, high performance windows, doors, everything. Now it has become smart. Earlier days, it was not so. Okay. So even for saving on to biogas, even we have mechanisms maybe at the back of your home. Yeah, it's quite possible. Okay. So now we'll try to control power supply of individual device components. Okay, so that's a very main important part in the energy saving strategy and the mechanism what we are targeting into. Okay, so there are several modular devices. Okay, we have electronic equipment designers managing all the power supply to various components. Okay, for example, integrated power management systems in smartphones can get access and it can control the power supply to the individual components. For example, the screens, what you're using, okay, the processors at the back, okay, and the communication modules which help into process. Okay. So we tend to go into a situation when the user does not use various Bluetooth peripherals. Okay. Communication module immediately can deactivate temporarily. Okay. So that can significantly go for energy savings. Okay. Right. So probably we are into like a usage of too many mobile applications. Yeah, it consumes a lot of energy. Okay, right. When a processor is not under load, its clock speed can be lowered or it can be switched to a lower power consumption mode. Okay, so that can significantly save the energy. Okay, so we have much more adaptability. We have much more flexibility. Okay, so that tailors the device operation to certain circumference systems as well. Okay. So as a general user, you can work longer on a single battery charge. That is what you call it to be optimization. Okay. So now we go into smart operating modes. Okay. So generally, in order to optimize this energy consumption, modern electronic devices often use various operating modes specifically to adapt to the current needs. Okay. So we have different modes. So probably everybody would know about these particular modes. Okay. These modes are very important tools that combats or maybe fights unnecessary energy consumption. First of all, there is a sleep mode where majority of the functions are off. Okay. And the processor switches to the minimum activity status. Okay. So that is a very important solution when the device is not operating for a longer period of time. Okay. So next one, you have idle mode. Idle mode means the device is on, but it's not currently involved in any particular active task. Okay. So here in this particular idle mode, the processor can actually lower the clock speed. It can reduce the power consumption. Also, you can respond immediately to any user activity. Okay. So for example, let us take in the case of a locked smartphone. Okay. But still you can access some of the features. So I'm trying to showcase to you so that you will try to better understand. Okay. Then we have deep sleep mode. Okay. So the device is off or maybe it is running with minimum intensity, but still it remains fully prepared for activation in response to a specified event. Okay. For example, you press the on button. That is how you have the deep sleep mode. Okay. Then you have standby mode. Okay. So standby mode, the device remains on and ready for operations, but still you're going to deactivate unnecessary components which are not adding any value. Okay. Which are not adding any use to the system. Okay. So that you can save considerable energy. Okay. So that's a very standard solution. You can use it in TVs. You can use it in other remote control devices even. Okay. So for all application oriented devices, you can use this standby mode. Okay. So this cut edge operating systems, especially when you are dealing with RTOS, okay, you can smartly manage all the device operation modes. So that is how you can save energy without any particular compromise on the performance. Okay. Right. So now we go for energy efficient data transfer. Okay. Probably we have IT device models, building energy model, building airflow model, HVAC model, power supply model. Okay. Right. So for example, our topic of concern is energy efficiency. Okay. So we have BLE, Bluetooth Low Energy, Zigbee protocols. They are becoming increasingly popular in application oriented, extending battery part operations. Okay. So Bluetooth Low Energy is how you use. Everybody knows about this one. Okay. It's a Bluetooth standard optimized for minimizing the energy consumption. So it's a general specific solution where low energy consumption is actually very important, specifically with smartphones or maybe IoT sensors. Okay, right. So as I told you, with like different modes, the devices can even enter into the deep sleep mode between shorter periods of operation. That can significantly increase the battery lifetime. Okay, right. So we also tend to use an existing technology, Zigbee. Okay, of course, several advancements have come into. Okay, so that's a low energy consumption communication protocol. Okay, so you can use Zigbee to 950 megahertz bands. So specifically for low power consumption, you can use them. Okay, you can even use these Zigbee devices in the sleep mode when power consumption is actually minimal, and only periodically enter active mode to exchange the data. Okay, right. So I'll try to show you an energy efficient data transfer process. Okay, we have the microcontroller or microprocessor. We have the internal or maybe external memory. Of course, we have analog to digital converter, digital to analog converter, sensors being fit. Okay, we have power source battery, transmitter, receiver modules as well. Okay, so a state of low power consumption can be achieved, okay, for specific events, for better communication between the equipments. Okay, that significantly increases the energy efficiency for IoT devices to operate in the hard to reach locations. Okay, so like remote sensors, built-in interior automation system components, we tend to go for energy efficient data transfer. Okay, also much more faster even. Okay, so for this one we go for some scenarios. Okay, overclocking processes and microcontrollers. So that might not be the way to actually save electricity, but it can be effective mechanisms. Okay, the idea is that you're going to increase the processor clock speed, and in that way you can actually accelerate, increase the operation performance. Okay, so because of this effect, the device can actually enter into the sleep mode, or maybe it can go with a low power mode. Okay, so that happens faster rather than later, which significantly reduces the overall power consumption. Okay, so it can be used for shorter periods of intense activity followed by longer idle periods. Okay. For example, a processor running at higher clock speed can perform tasks much more faster, which means that it has longer sleep period, which for which the power consumption is actually minimal. Okay. So try to understand that overclocking is not a universal subjective solution for each of the issues. Okay. That is actually suitable for every electronic device. Okay. So that is not the case. Okay. But in some cases, rare cases, it might lead to increased power consumption. So especially when the device constantly operates under load, and higher clock speeds do not translate into reduced operating time. Okay. So then we go for temperature control. Okay. So that is a very important energy saving strategy. When the temperature increases, definitely the components will consume more current. Okay. So if you try to think about energy saving, then controlling the temperature would be the apt solution. Right. So before going into the temperature control in detail, I think let me show you some little glimpse about SUSMAT project. So that was one interesting thing I came to the today's scenario. Okay.
Sustainability for me is the action we need to take to maintain the natural resources. My research group is a photonics group that specializes in optoelectronic devices, and in particular devices that emit light and detect light. The sustainability goals in my group can be summarized into two. Our first goal is to make optoelectronic devices more efficient and more reliable, so they will last longer. They will consume less electricity when you are using them, and you will not have to buy these devices again and again. The second goal is to develop novel and ingenious methods to fabricate optoelectronic devices without consuming a lot of electricity and having basically neutral environmental impacts.
In my research, I'm working on building blocks of modern infrastructures, data centers, smartphones, laptops. So in my research work, I'm improving the building blocks of these new infrastructures, semiconductor components and devices. I'm trying to make them more efficient, so they will use less power. And in case of, for example, solar cell, which is another kind of infrastructure, it produces more energy with the same amount of sunlight and same area of the cell if we are able to improve the efficiency of the semiconductor there, which is silicon.
Mä tutkin sitä, että miten esimerkiksi elektroniikkaa voidaan tehdä energiatehokkaammin. Että meidän energian kulutuksesta yhä suurempi ja suurempi osa käytetään datan käsittelyyn, tietokoneisiin ja sen sellaisiin. Nämä neuromorfiset piirit, mitä me tutkitaan, niin niiden avulla voidaan tiputtaa tietojen käsittelyyn käytettävää energiamäärää kertalukuja pienemmäksi ja se tehdä samalla tehokkaammaksi. Mä tutkin myös korkealämpötilan suprajohteita. Ja suprajohde on sellainen aine, jonka resistanssi on 0, kun se on tarpeeksi kylmä. Ja aika helposti pystyy ymmärtämään, että miten se, että joku moottori tai generaattori ei lämpeä ollenkaan, niin voi vaikuttaa siihen energiatehokkuuteen.
So probably this is a glimpse of a SOSMAT.
Well, Singapore has launched one of the world's first standards for making data centers more energy efficient and cost effective. The guidelines by the Infocom Media Development Authority show how these facilities can raise operating temperatures in a tropical climate and at higher humidity levels. Currently, most data centers operate their equipment at 22 degrees Celsius and below. This means cooling systems can account for up to 40% of their total energy consumption. The IMDA standard aims to help these centers gradually increase their operating temperatures to 26 degrees Celsius and above. IMDA says it's been tested with several operators, including Digital Realty across 2 of its data halls. The company managed to raise temperatures by 2 degrees Celsius and reduced its total energy usage by 2 to 3%.
The IMDA standard is a great initiative to provide us with a guideline to initiate discussions with our customers on increasing set point temperatures in our data centre, and it allows us now to have a path forward with our facilities, not just our existing facilities but new facilities as we build into the future.
As demand for data centers increase, energy efficiency will be critical to ensure the sustainable growth of this industry. These standards will help operators determine the best operating temperature and conditions to optimize energy efficiency, while at the same time safeguarding operational reliability.
So look,
So let us go ahead with the temperature control. Okay, so that's very, very important. So probably if a suitable low temperature can be maintained, electronic components will operate much more efficiently. Of course, everybody knows about this one. Okay. For mobile devices, maybe like smartphones, laptops, temperature control involves managing the fan speed. So probably when you're using the laptop, like sometimes you hear a very high fan speed. Okay. So probably it is actually maintaining the temperature. Okay. Maintaining several applications in use, or it is actually adjusting the processor performance to ambient temperatures. Okay. So it's very important to avoid excessive or maybe like active cooling, which can actually increase energy losses. Some case in extreme conditions like frost or maybe heat, devices can consume more energy to maintain the right operating temperature. Probably the region where I am actually situated, like there is too much of cold. Okay, so probably to manage that, the devices should consume too more energy to maintain that particular temperature. Okay. So optimizing the temperature in electronic devices requires analyzing complex relationship between environmental sustainability and their impact on the circuit operations. Okay, so there are some tips for improvising battery life. So we consider this as a checklist. Okay, try to create a battery budget, set the input output to the low power, use processor power modes, turn off all unused processor peripherals, control the external peripheral power, optimize the program flow, try to increase the clock speed to finish processing much more faster, and of course use a buck converter or maybe low dropout linear regulator. Okay, so first of all, try to list out all your components. Write down what is your active low power current consumption. So you will measure these values on your own form factor board or maybe development board. Estimated consumption numbers can be actually calculated using these particular values. Okay, determine the time your device will be in active as well as low power modes. That will be the challenge for several real-time projects in use. Okay, so let us take in the case if the average numbers are not known, so you can estimate the worst case scenario. Okay, so the time can be presented in seconds, milliseconds, or it can be presented as a percentage of the day. Okay, so calculate the average current consumption by adding up all the active as well as low power mode consumption numbers, divided it by the summed up time. Okay, so this is the formula. Active current multiplied by time in active plus sleep current multiplied by time in sleep divided by the whole divided by time in active plus time in sleep. Okay, so that's how you try to determine the battery size. To get the required mAh, multiply your average current with your target operational time. Try to choose a higher mAh rating than your desired one. Calculate the estimated battery life. So battery mAh divided by average consumption, that gives the total battery life. Okay. So then you try to set the input output to the low power. So put your input outputs into a low power mode. Okay, because it blocks all the small amounts of current from escaping, what you call to be leakage. Okay, so it's very important that most of the microcontroller unit come into input outputs already turned off at the boot. Okay, so the primary goal is to ensure that the current is actually not flowing into or out of the GPIO. Okay, so when we are actually sleeping or maybe we are not using that particular component. Okay, so exact settings you want to use are going to be system dependent. For example, higher Z inputs will work for some situations where the GP general purpose input output is expected to be very low. Okay. But it may also cause a particular signal to float that can cause a considerable peripheral to unexpectedly draw current. Okay. So maybe if the signal defaults to 3.3 volt and it should be driven low to active, the general purpose input output should be needed to set input with a pulled up enable. Okay, so also you try to note that your peripherals may have internal pull ups or maybe pull downs that you need to account for. Okay, so this is the thumb rule. So if the peripherals input output is actually low at the target mode, then ensure that the general purpose input output is programmed either at the input without pull up pull down, okay, or high Z value, or as an input with pull down. Okay, so try to confirm the exact usage by monitoring the power consumption. So you need not have this pull down. Okay, right. So if the peripheral input output is generally in high in the target mode, make sure that you try to ensure that the general purpose input output is programmed either as an input without the pull up pull down, which means high Z value, or as an input with pull up. Okay. So this is the starting point for GPIO settings. Okay. Try to confirm the exact usage by monitoring power consumption to ensure you don't need the pull up. You can check the current draw through the pull up or maybe pull down resistors on your board to ensure there is no unexpected current drain through the resistors when in the low power states. Okay. So try to confirm the GPIO optimizations are having the expected effect. Okay. So use processor power modes. So some processors have some standby modes that can be configured, which automatically change the GPIO state when the power mode changes. Okay. So every MCU, as I told you earlier, it has active, sleep, and deep sleep. Okay, right. So for example, STM32L, it supports the following power modes. For example, it has sleep mode, where the CPU core is actually stopped, RAM as well as register contents are retained. Specific chosen peripherals are actually active. Okay. So CPU can be woken up by any of the active peripherals, and the current consumption drops to 400 microamps to 1 milliamps at 16 megahertz clock rate. Okay. Then we have low power sleep mode. Okay. So CPU core is stopped and the active peripherals are limited depending on what is actually active. So CPU will wake from the RTC interrupt. Current consumption drops to 3.2 microamps. Then we have stop mode. So CPU core is stopped, but RAM and register contents are retained. Most of the peripherals are stopped. Then stop mode with RTC. Okay, so wake up signal is an external signal. Of course, you know about it. Current consumption drops to zero point 0.8 microamps. Stop mode without RTC. Okay, wake up is only the external signal and the RTC is actually stopped. Here the current consumption drops to 0.38 microamps. Okay. Standby mode. So here the CPU core is stopped, registers and RAM are actually stopped. Okay. We also have standby with RTC, where wake up is external or with RTC. Current consumption drops to 0.57 microamps. Okay. We also have standby without RTC even. Okay. The RTCP is stopped also. Current consumption even drops to 0.26 micrograms. So you should note that some processes will have power settings modes, where others it will control their power consumption by increasing the clock speed or maybe decreasing the clock speed. Okay. So unused peripherals are simply wasting the power. So that's where you turn off the unused processor peripherals. Make sure you disable them at boot. Okay. You will also want to disable peripherals whenever they are not being actively used by the system. Okay. So we have active mode, ESP32 core, CPU memory, radio, peripherals. We have RTC, low power peripherals even. Okay. So that's how we use. Okay. Active state, inactive state, we tend to measure. Okay. So just like we want to turn off processor peripherals, we might also want to control the power state of external peripherals on our board. Okay. So prefer to select the sensors that either has a enable pin or it can set into sleep mode. Okay. So if your sensor doesn't support these particular functions, generally you can use a simple switch. Like for example, we have DMG 231L P-channel enhancement mode MOSFET to actually cut down the power to your sensors whenever they are not being used. Okay, so we have a simple schematic. Okay, here in this particular example, a MOSFET and a transistor are used to switch power to the load, and the load will be the external peripheral. Okay, so here we are going to optimize our application so that we are spending as little time as possible in the MCU's active mode. Okay, so which means that it generally mean simplifying calculations, batching operations, selecting alternate low power communication protocols, or simply you're going to collect the data and processing in the high power device. Okay. So finally, we are going to optimize the program flow. Okay. So that is where you're going to go for executing the code when there is much more work to save the energy. Okay. One way to do is by transitioning to the asynchronous as well as interrupt driven design. Okay. So that is how you try to have an advantage over the loop driven approach. Okay. So instead of polling these particular devices, interrupts notifies whenever there is an event that we need to respond to. Okay. So we can program our processor to monitor for a GPIO interrupt event, which is tied to the INT pin of the magnetometer. So here when the magnetometer detects a value above the program threshold, so here we are going to set the INT pin to high, triggering a wake up event on a microcontroller unit. Okay, so we no longer have to have this MCU wake up periodically to poll the sensor status. Okay, so this is very important life-saving tip. Okay, so select the components that provide the interrupt line and make sure the line is actually connected to the processor and used up by your particular software. Okay, so out of all these devices, for example, solar, wind, battery, renewable energy, substation, EV charger, decarbonization report, market data, agriculture, um, we tend to use softwares like building management systems, HVAC, building optimization. We have PLC, SCADA, we have accounting software even for optimizing the flows. Okay. So then we go for increasing the clock speed to finish processing much more faster. Okay. So faster. Everybody wants faster. Okay. So that's how you try to execute the algorithm much more faster. Okay. So that's a logical conclusion. That's how you try to increase the clock speed. You increase the power consumption of your device. Okay. And at the same time, you try to decrease the time that your process is actually spending in the active state. Okay. So every processor has a particular section in the data sheet, if you can see. Okay. And the power consumption per megahertz that is also being there. Okay. For example, for STM 32L072X8, we have down to 93 microamps per megahertz in the run mode. Okay. Increase the clock speed to estimate the trade-off for increasing the clock rate. You have to calculate how much time it takes to execute your algorithm depending on the current clock rate. Okay, so multiply the execution time by the consumption per megahertz. That will enable to find out uh, more power efficient to run in a high clock state to minimize the time in the active state. Okay, right. So finally, we are going to end this topic as of now with the buck converter or maybe low dropout linear regulator. That's how you try to convert excessive power into heat. Okay. So LDO is actually very perfect. Generally, if efficiency is not that important, because probably this LDOs will go around like 60% till 80% efficiency. Heat is not actually a problem. Okay. The input voltage is slightly higher than output voltage. Current is very small, under 1 ampere. Your budget is low, okay, and need for smaller port size, okay. So for this one, a buck converter stores the power in the inductor. Generally, it provides 80 to 95% efficiency, but it will take more space on your board and from your budget even, okay. So buck converter should not be put near like very sensitive analog circuitry because the electric noise that generates will be a issue. Okay. So efficiency differences we trying to see over here. Okay, between LDO and buck converter. Okay, so output current in ampere versus efficiency. Okay, we have switching converter, linear regulator. Okay, we can estimate the efficiency of this LDO. Okay, with a calculation. Okay, so input voltage 4.2 volt, output voltage 3.3 volt, current 250 milliampere. Okay, so we know power is equal to V input minus V output. Okay, multiplied by IP. Okay, so which is equal to V input minus V output multiplied by I. Okay, so 4.2 volt minus 3.3 volt multiplied by this 250 milliampere. Okay, so that gives 0.225 watts. Okay, so that's like if you see 0.225 watts, efficiency is being calculated. Efficiency is equal to V out divided by Vn multiplied by 100. Okay, so that will be 3.3 volt multiplied by 3.3 volt divided by 4.2 volt multiplied by 100. So that's actually 78.57. Okay, so with these same values as the buck converter, like the ADP 1147, generally if you see in the data sheet, okay, so that accounts to a value of 92.5% for the efficiency. Okay, so that's how you tend to compare the efficiencies. You are significantly saving this energy. Okay, right. So we also have a practical case, buck converter versus linear voltage regulator. Okay, it's a practical comparison. So let us go into this particular thing.
buck converters, and they make a great alternative to linear voltage regulators. In this video, I'll show you in practice why and when you should consider using buck converters. Linear voltage regulators, like this commonly used LM7805, are so cheap and so easy to use. Just supply those two pins with 7 to 16 volts. Add a 10 microfarad capacitor on the input. Another one on the output. And you get steady 5 volts. As we all know, nothing's perfect, and so are linear voltage regulators. They are quite inefficient because they waste energy and produce a lot of heat. How much heat, you may ask? Let's take an example. If you want to feed your voltage regulator with 9 volts and draw 500 milliamps on the output, you will have to dissipate 2 watts of heat. The temperature of your LM7805 will definitely go above 100 degrees Celsius or 212 degrees Fahrenheit. If you want to draw even more current or increase the input voltage, you might need a big heatsink or use a buck converter. Probably all computer power supplies utilize buck converter circuitry to maximize efficiency. You can buy buck converters in different shapes, sizes, and with different specifications. Another name for a buck converter is voltage step-down converter, which describes its purpose pretty well. You feed those two pads with DC voltage, and you get constant lower voltage here. The output voltage is adjusted by this potentiometer. For example, you can set it to 5 volts, and this little guy becomes a very efficient 5 volts voltage regulator. Let's compare in practice the already mentioned LM7805 linear voltage regulator with this really small buck converter. Both are given 12 volts on the input, and they provide 5 volts on the output. The driver boards from these old hard drives consume approximately 450 milliamps, and they will serve as my dummy load. I will measure the power consumption and temperature of the linear voltage regulator and the buck converter under the same load 15 minutes after powering up. Only 2 minutes later, the LM7805 consumes about 420 milliamps at 12 volts. But as you can see, the power consumption drops to 0 and then goes back to 420 milliamps over and over again. The LM7805 shuts down if the temperature goes too high. It can operate properly up to 125 degrees Celsius or 257 degrees Fahrenheit. Then let's check the temperature. As you can see, it's well above the safe range, so the regulator shuts down and turns on after cooling down a bit. The linear voltage regulator draws 420 milliamps at 12 volts, which gives us 5.04 watts. Now let's check if the buck converter can finish the same test. After exactly 15 minutes, the buck converter draws only 220 milliamps at 12 volts, which is only 2.64 watts. In this configuration, the linear voltage regulator consumes over 90% more power than the buck converter, which is worth considering especially when your device is battery powered. Now let's check the temperature. As you can see, the buck converter stays at only 38 degrees Celsius or 100 degrees Fahrenheit. In this example, the superiority of the buck converter is very clear, but you can buy an LM7805 for about 30 cents, while the cheapest buck converter will cost you about $2.50. There's one more thing, because buck converters use coils, they may cause interference in your circuits. So if you're building something sensitive like a radio for example, you should grab a linear voltage regulator and live with all its drawbacks. On the other hand, when you are designing a device in a small enclosure, where proper airflow cannot be provided, a linear voltage regulator with a big and hot heatsink is probably not a good idea. Now you know the main advantages and disadvantages of buck converters and linear voltage regulators. If you have any questions or want to add something, feel free.
That gives a practical example of buck converter. Okay, significantly saving energy, temperature control even. Okay. So probably in this session, we had a brief overview about how you can increase the clock speed to finish processing much more faster. We use several processor power modes even. We control power supply of individual device components. We went into several smart operating modes. Of course, we ended up the session with comparing buck as well as LDO efficiencies as well. Okay. Thankfully, several researchers, specifically like masters, even more of the doctoral candidates are working towards energy saving, of course, battery consumption even. Probably there is a fever going on in India, quantity over quality. So I think that has to be cut short. Uh, Also, people should more focus towards coming out with granted patents, specifically in this particular field. We have several international patents, not only Indian. Indian, of course, I can definitely say Indian is a very hard patent, hard way to get an Indian patent with grant. Okay, of course, there are several international patents. We have Korean, we have Japanese, Chinese. German is very easy. Australian is very easy. Probably they are going to be phased out very soon. Okay. You can try with several patterns. Patterns are the future. So you can come out with several patterns. Of course, everybody comes out with SCA research papers. As I told you, quality matters over quantity. So that is the key situation to be taken over in this particular topic, from this particular session even. Okay. I'm sure you got some basics out of it, and probably that is the main concern over this particular event. So once again, thank you, my dear organizers. Of course, the coordinators who handle this session so effectively. So if you have any questions, you can ask.
Thank you, sir. From participants, any questions?
Suppose again, reminding our people, if you would like to collaborate on patterns and of course in good SCI research papers, yeah, you are most welcome. Again, I'm not into quantity, I'm into quality. So yes, if you are into useful collaborations, useful research collaborations, definitely you can contact me.
Any questions from the participants? Okay, so thank you. Thank you for your
Okay,
insightful
sir.
presentation on the topic optimizing power consumption and enhancing battery life, sir. The
Okay,
presentation
sir.
is very useful, and along with videos, we have gained so
Okay.
many things. Thank you, sir.
Okay. Okay, sir. Fine.
Thank you.
So anybody who wishes to collaborate, yeah, you can. You are most welcome. Not only the organizers, but also people who are there. Come out with more collaborations. Again, reminding you, don't go for more quantity. Uh, you are coming out maybe with 5 research papers, even 10 research papers uh, within a year. That also would be great. Don't focus on quantity. That is what institutions are more focused into. Please let us change the mindset. Let us focus on quality. Of course, the greater potential lies in India. So please let us focus towards that and be more futuristic. Don't
Sure,
just
sir.
focus on the situation. Okay, thank you.
Sure, sure.
So
Thank you, sir.
yeah, so she has asked my email ID. My email ID is, yeah. So this is my email ID, Professor Shubha Rao. So you can contact me anytime. Uh, Probably anybody can do that. Okay. So probably from there I will take you to my WhatsApp and we can interact. Okay.
Thank you, sir. Thank you for sharing your email, sir.
Thank you. Thank you, sir. Thank you, everybody.
Thank you, dear participants. Please complete the feedback form for today's session. Thank you for your active participation. Kindly join tomorrow's session at 5:50 p.m. Thank you all. ஆமாம் சார் கேட்கலையா சரி ஓகே சார் ஓகே Dear participants, kindly fill the feedback form for today's session. And for tomorrow's session, join at 5:50 p.m. Thank you all.